All right, everyone. Sorry I was a few minutes late. Had a little trouble with my streaming software, a little trouble putting the 2-year-old to bed, but I am all set now. Okay. Hopefully everyone can hear me. Okay. If you can't, then for sure let me know. I'm gonna have to keep this to just a half an hour or so because I've got to do another one immediately after this. I'm not even stopping. I'm literally just going to switch over mid. So I'm going to go over as much of this as I can. But if there is something specific that you need me to go over, please let me know, and I will do my best to make sure that I can get to it. Okay. So for the first two, honestly, these are not too bad, but the biggest thing to remember is what things should look like when we plug in for variables. So when you're plugging in for negative 2x to the third, biggest thing you want to remember is when you're plugging in for a variable, you should use parentheses just around where the variable was. Exponent still goes on the outside of those parentheses, though. What this ensures that you do is that you actually use the exponent exactly that many times, okay? Use the negative sign the number of times of the exponent. Okay, so like order of operations here, we would do negative 3 to the third first, which is negative 27, and then multiply by negative 2 to get negative 50, to get positive 54. Same thing for B. You would really do the exact same thing. You would plug in the 4 in parentheses. Here, the parentheses don't do a whole lot other than kind of re-emphasize that we need to do 4 times 4 times 4 first, which is 64, and then multiply by the negative 2 to get negative 128. Over in number 2, here the parentheses really do make a pretty big deal when we're plugging things in that we've got to make sure we're using the negative sign the proper number of times. And we've got to make sure that we're doing the exponents first and not like doing something weird where we multiply the numbers together first. So 4 cubed is 64. It's going to be negative 64 because we're using the negative 3 times. 2 to the 4th is 16. That'll be positive, though, because we're going to get 4 negative signs from there. 64 times 16 is 1,024. And it's negative because we had a negative times a positive. So for A, it should be negative 1,024. And for B, we should be plugging in negative 2 for X and negative 3 for Y. We're going to get negative 8, and we're going to get positive 81. And 8 times 81 gets us 648. So we're going to get negative 648. That's pretty much it for our straight plugging in numbers stuff. The biggest issue that I often see there is that people just plug things straight into their calculators, right? So if you plug something straight into your calculator, you've got to be a little bit careful in that you need to really make sure, and I should scroll back up here, you really got to make sure that it kind of looks exactly like this. You do want to put parentheses around those numbers. Okay, close the parentheses, then the exponent over here using the second number in parentheses 2, right? Because otherwise, if you do negative 2 to the 4th on your calculator as an example, without using parentheses, it'll give you negative 16. With using parentheses, it gives you positive 16. You've got to use parentheses when you're plugging in for a variable. Okay, for numbers 3 and 4, we're kind of using the same rule here. So we're going to be multiplying the numbers and adding the exponents. We're adding the exponents simply because we're just counting up the total number of variables. And we're not adding the numbers on the outside because they're not exponents. So they're not telling us how many of a total thing we had. We can multiply 4 and 5 and get 20. And then we've got 3 x's and 7 x's. That makes 10 x's. For number 4, here's why I like to stress that the rule of adding exponents is really just about counting the variable. Okay, I think most are probably going to be okay getting negative 36 when we multiply all those coefficients together. However, most people give me, not most people, I should say, some people give me y to the 12th. You should get y to the 13th here. If you just go by straight exponent addition, it looks like the only two exponents are 3 and 9, so we get 12. But remember, y is the same thing as y to the first. There's an imaginary 1 there that we should be adding in there too. Or if you just think about it as counting y's, it's 3y's plus 9y's plus 1y. That's 13y's. In number 5, we're bringing in our distribution rules. Okay, so we're going to distribute that exponent here, here, and here. Oops. Try again. We're going to get negative 3 to the 4th. Notice I'm still using parentheses around the negative there. X to the 16th and y to the 4th. The only thing then that you have to evaluate there is negative 3 to the 4th power, which I'm pretty sure we did up above, so that's 81. We are multiplying exponents there, but for actually two of the things we're distributing to, we're not so much multiplying exponents as giving it an exponent, because it didn't really have one right away, though I guess you could consider those being exponents of 1. For problems like number 6, I find it easier, and I'm going to try to not make this look awful. I try to think of it as 3 separate fractions. Pretend I did that better. I'm going to erase just so we can actually see what's there. You're kind of simplifying them all individually. So 48 over 20, it's just a regular fraction. The least common multiple, or excuse me, the greatest common factor of 48 and 20 is 4. So I'm going to divide everything by 4, and I'm going to get 12 and 5. For our exponents, though, we're just canceling things out here or subtracting exponents. 3 cancel with 3, we get 13. And 13 cancel with 5, and we get 8. For 7, we're going to go back to distributing exponents. Okay, so we're going to get x to the 10th. Oops, excuse me. Trying again. Over y to the 12th, and that's it. Nothing we can simplify there. You cannot simplify the 10 over the 12 because that would be like canceling out x's and y's, which doesn't really make a whole lot of sense. For 8, we're going to get x to the 8th, y to the 8th, over y to the 6th. Cancel out 6 of those with 6 of those, and we'll have 2 left. For number 9, we're going to do exponent distributive property. So 2 to the 5th, x to the 25th, y to the 20th, over 2 squared, x to the 4th, y to the 6th. Now you have a couple options for what you could do with the 2's there. You could change 2 to the 5th into 32 and 2 to the 2nd into 4 and then divide those numbers. Though if you have exponents on them, you can cancel 2 of these 2's with 2 of these 2's, just like you're about to do with the x's and just like you're about to do with the y's. And then you would end up with 2 to the 3rd, x to the 21st, y to the 14th. The only thing really left to do after that is evaluate 2 to the 3rd, meaning do the exponent. 8, x to the 21st, y to the 14th. Okay. That kind of brings us to the end of our first page. If you've been asking questions and I have been answering them, I actually don't see the chat window on my screen. I kind of got to go back and forth window. So I do check these periodically. Okay. Sid asked, should you just get rid of the denominator and would you take off points if we still have it? There's really no, I'm not sure which denominator you're talking about, but for the most part, you can kind of write things with denominators, without denominators. It kind of depends, right? So the only one in that previous set in which we needed a denominator was number 6. Okay, number 6, we kind of needed a denominator, right? We needed the 5 in the denominator. However, you could have written it as 12 over 5 and then x to the 13th, y to the 8th. That would have all been okay. Number 7, we also needed a denominator. I suppose you could have written for that one x to the 10th, y to the negative 12th. For number 7, that would have totally worked out as well. But for the most part, though, I think the rest, kind of the way I wrote them was probably pretty much the way that you needed to go there. Okay. So let's take a look at a few others. So now for numbers 10 and 11, here's where you could kind of go multiple different directions. If you wanted to go with exponent subtraction, you would just write x to the negative fifth. You'd do 5 minus 10, and you get x to the negative fifth. If you want to go the cancellation route, you could cancel 5 of these with 5 of these, and you'd be left with 1 over x to the fifth. Okay. Either of these answers is totally acceptable. It really doesn't matter which one you put. You don't have to put both. And either one of them would work totally okay. Same thing with number 11. You could write a to the negative sixth, b to the negative fourth, or you could write 1 over a to the sixth, b to the fourth. It doesn't really matter, again, which one you put. Both of those would totally be acceptable because they mean the exact same thing. Number 12 is where we kind of encounter a problem. So you're going to distribute your exponent, and I would suggest not doing anything with 2 to the negative third initially. And what I would expect you to kind of do then is say, okay, I don't need to do anything with x to the negative 12th or y to the 9th. You could leave those, but you're not allowed to just leave a number in an exponent. You have to evaluate 2 to the negative third. Remember, anytime you want to turn a negative exponent positive, it becomes a fraction. So that would be 1 over 2 to the third. It's your choice as to whether or not you want to also do that with the x's. So one option is just doing it with the 2's and writing 1/8 x to the negative 12th, y to the 9th. If you also did it with the x's and kind of combined them into one fraction, you'd get y to the 9th over 8x to the 12th. Sorry for the kind of weird fraction bar there. Okay, we would just do that. All right. For 13, this is where kind of your method can maybe get a little shaky. If it were me, I might consider changing all of these to positive exponents. You can just go straight exponent subtraction here, but my initial change might be to just make this s to the 18th, make that s to the 6th, leave my r's alone because they're already positive exponents. But I think reframing the problem this way kind of makes it just a little bit easier to deal with. Canceling 10 and 40 to 1 and 4, and then canceling 6 of those with 6 of those, canceling 6 of those with 6 of those. We would have 12 s's left on top because 6 of them canceled from the denominator, a 4 left in the denominator, and 6 r's left in the denominator because 6 of them canceled with up top. And then kind of the last one in our variables section here that may or may not involve some negative exponents. Distribute your exponents first over here. You can't do any canceling right away because you've got to follow order of operations. And then you can, we've used the phrase cross cancel before. It's not my favorite phrase, but you can use it. So 10 of these cancel with 10 of these. You've got 18 left. And 8 of these cancel with 8 of these. You've got 32 left. No need for negative exponents there at all because we really don't have any. Okay. So scrolling back through questions. I'm not going to say 0 exponents won't be on the test. They could potentially come up. Where they came up on your first review assignment was kind of in scientific notation a little bit, but not really too much there. I would kind of focus on, just knowing what negative exponents are. That's the much bigger emphasis here. Okay. What do you want us to round to, tens or hundreds? We will get there when it comes to rounding. Now, I will say this, as far as like number 12 goes, especially, I wrote that as 1/8. You should also write that as 1/8. There's no real reason to use decimals there. Okay. So I would really strongly suggest that you just leave that as a fraction. Now, we are definitely going to need to use some decimals down in the scientific notation area. And I'll kind of talk to you about that, but there really shouldn't be a whole lot of need for rounding there. Beatrice asked, how did you get y and x separate? I'm guessing probably talking about, if correct me if I'm wrong, Beatrice, but I'm guessing you were talking about number 14. For number 14, really just what you got to do is you can consider them things that you can cancel, because if I were to kind of go back a little bit, when we're right here, if you were to multiply those fractions together, they would just become kind of one numerator and one denominator. So there's no real reason to treat them as two separate fractions. You're okay canceling there. Beatrice, if you were talking about number 12, when I kind of did this, I turned that into 1 over x to the 12th to kind of make it one fraction with the 1/8. And then I put my y to the 9th in my numerator. But again, that's not something you have to do. And again, you don't have to write two answers for any of these. One answer is totally sufficient in this section. Okay? Okay. Hopefully that was helpful. So, all right. Rewriting in scientific notation. So again, the big thing to remember is that positive exponents mean we're going to be multiplying, so meaning it's going to be a bigger number than 10. Negative exponents mean we're going to be doing a smaller number than 10. So what you kind of see me doing in each of these cases is immediately changing the number to be something between 1 and 10. Okay. So I've changed 23 million into 2.3, number 16 into 2.35, number 17, I changed it into 5.4. Now I just have to figure out in each of these cases what the exponent is. For number 15, what you're asking yourself is, how many times would I have to either multiply or divide 2.3 by 10 in order to get it to be back to that original number? So I'd have to multiply by 10 7 times. So I want that to be a positive 7, because I'd want to be multiplying by 10 7 times. I would essentially have to move that decimal place 7 times to the right. For 2.35, I would be dividing it 4 times. I'd be moving that decimal place to the left 4 times. For number 17, it was almost in scientific notation to begin with, but not quite. So basically, this is a whole thing where I don't want to change the value of this number, but what I had to do is I had to lower the value of my 54 to 5.4. So I'm going to increase the value of my exponent to make it go from -6 to -5. Now I know I've got something that's the exact same value. Okay. So really, that's kind of the key to writing numbers in scientific notation. Okay. Hang on, guys. I'm going to pause for one quick second. All right, we're back to it. So, here's what we're going to do now. Now we're doing multiplication and division with scientific notation. When you are multiplying, okay, when you are multiplying, you're going to multiply the numbers. So 5 times 3 is 15. And you're going to add the exponents. 3 plus -7 is -4. The only thing you really have to pay attention for then is is your answer in scientific notation. In this particular case, unfortunately, it's not, because 15 is not between 1 and 10. You've kind of got to make the same adjustment that you made before. I'm going to need to drop my 15 down to 1.5, and I'm going to need to increase my -4 up to -3. For 19, this is where it becomes, I think, slightly different than our normal exponent problems, okay? So the difference that we have here is that 2 divided by 4, normally we would just change that to a 1/2, but we can't leave it as a fraction because we need decimals for scientific notation to take advantage of our powers of 10, okay? So with that said, we're going to write 2 divided by 4 is 0.5. We're still going to subtract our exponents, though, okay, and we're going to make that 10 to the 4th. Again, that number is not between 1 and 10. We're going to have to change that to a 5, which means we're going to have to lower our exponent to make sure we don't change the value of that number, okay, that little seesaw effect. Last, for number 20, again, 3/5 is not a fraction we can simplify, but writing it as a decimal would be a 0.6. Subtract your exponents, you get -2. Again, we've got to make the same adjustment that we made in the last one, and we get 6 times 10 to the -1. Okay, so looking at some final questions. Sydney asked, for multiplication, are you adding, and for division, are you subtracting for the exponents? Anjali already answered, and yes, that's definitely true. So kind of where some of I think that's the one place where you really need to know that, yes, when I'm multiplying, I'm adding exponents, and then when I'm dividing, I'm subtracting exponents. There are other places where you can just kind of go with canceling, or you can go with, just kind of putting all those things together, right? But that's one place where you definitely need to know, yep, when I'm multiplying, I add exponents. When I'm dividing, I subtract exponents. Tomorrow on your test, you will definitely need, you will be able to use a calculator. But the one thing that I do want to stress very, 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 very much, okay, is that not everywhere will be super helpful with a calculator. It's helpful for coming up with numbers, but like, for example, this whole top section right here, you've got to be very careful when using a calculator and make sure that if you're using it, you're making sure you're using it right and that you're really understanding how those exponents work, because otherwise your calculator may not help you. I would use your calculator very much as just something to aid and help you and deal with some of the bigger numbers that can be involved with exponents, and not something that you're relying on completely. Okay. Beatrice asked if I could do something similar to number 14. Sure. I actually have a few minutes before we need to switch over. Oh yeah, sure. I can do something like when the number 14, except I'll try to make it a little bit different, maybe. Let's see. Let me just add, there we go, blank page. Okay. So just as another example for something like that, let's go with x to the 4th over y to the 3rd. Let's make that all to the 3rd. And then we'll make it y to the 5th over x to the, we'll also go to the 4th there, and we'll make this all to the 4th. Okay. So again, in this example, you would basically be distributing exponents, multiplying them. And then next, this is where I think it's helpful to just kind of rewrite those as one single fraction, combine them together. Okay. And now if you kind of look at it, you could do this now with either exponent subtraction or cancellation. You'll probably notice if you do it with subtraction, you'll get a negative for your x's, but you'll get a positive for your y's. You could also do it with just cancellation. So that's a possible answer. Or You could say 12 and 12 cancel, and we're left with x to the 4th in our denominator, and we're left with y to the 11th in our numerator. Honestly, both of those answers are equally good, and they're really both equally fine. Okay? If you have any more questions, stop by and see me tomorrow morning. You guys actually don't take yours until sometime later in the day, so you could also stop by during recess as well. And hopefully this was at least a little bit helpful. Thanks, everybody. Have a great night, and we will see you tomorrow.